Okay, kind of a simple lesson here for you today. I think that you're due for one. Distance and midpoint formulas. So, on a coordinate plane, if we have a couple points, let's call them x1 and y1 and x2, y2, we can find the distance between these 2 points from this formula. And what this is a variation of the Pythagorean theorem. It's the sum of, the difference of the x values squared plus the difference in the y values squared, and then you take the square root of that sum, and you get the distance between the 2 points. The midpoint, halfway between these 2 points on a coordinate plane, can be found by adding the 2 x values and dividing by 2. That'll give you the x value of the midpoint, and you add the 2 y values together and divide by 2. That'll give you the y value of the midpoint. All right. So if we had these 2 points plotted on a coordinate plane, we could use well, we don't even have to plot them on a coordinate plane. We can find the distance between these 2 points by using the distance formula. So x sub 2 is 4, x sub 1 is 3, y sub 2 is 0, and y sub 1 is -1. So instead of 0 minus -1, I always just put 0 plus 1 right off the bat. All right, now we're doing order of operations. 4 minus 3 is 1. 0 plus 1 is 1. 1 squared is 1. And 1 plus 1 is 2. That's our answer. That's the distance between those 2 points. Probably makes more sense, though, if we approximate it to about 1.41 units away. So if you plotted those 2 points and drew a straight line between them, that would be how long that line is. Are -2, 3, -1, 1, and 2, 3 the vertices of a right triangle? Well, to do that, how about the Pythagorean theorem? We should definitely use that. So let's call these points A, B, and C, and let's find the distance between A and B, the distance between A and C, and the distance between B and C. That'll be the 3 sides of our triangle. So for A, I'm doing -2 minus -1, -2 minus -1, or plus -1. And then I'm doing 3 minus 1 for the y values. Follow order of operations, and I get the square root of 5. Not going to bother turning that into a decimal. All right, now let's find the distance from A to C. So we'll do -2 minus 2. That's the difference in the x values squared. And then 3 minus 3. That's the difference in the y values squared. And then we'll follow order of operations. -4 squared is 16, and 0 squared is 0, and so let's just leave it at square root of 16. I could make that into a 4. You'll see why I'm not going to bother here in a second. All right, now lastly, let's find the distance between points B and C. -1 minus 2, that's the difference in our x values, and 1 minus 3, that's the difference in our y values. Follow an order of operations here. 9 plus 4, take the square root of that. That'd be square root of 13. Again, I'm just going to leave that as the square root of 13. Now, if these are the side lengths of a right triangle, then they should fit in the Pythagorean theorem. So the shortest side squared plus the next shortest side squared should equal the third side squared. So square root of 5 times the square root of 5 is 5. Square root of 13 times the square root of 13 is 13. The square root of 16 times the square root of 16 is 16, just like 4 times 4 is 16. there's really no need to change these out of square roots if you're just going to square them anyway. At any rate, 5 plus 13 is 18, which does not equal 16. So that we know that 5, 13, square root of 5, square root of 13, square root of 16 are not the side lengths of a right triangle. So these are not the vertices of a right triangle. Player kicks a soccer ball from a position that is 8 yards from a sideline and 15 yards from a goal line. The ball stands at a position that is 30 yards from the same goal line the ball lands at a position that's 30 yards from the same goal line and 55 yards from the same sideline. So how far was the ball kicked? Well, they've just given me some ordered pairs here. I'm going to set this up instead of x, y, I'm going to say it distance from sideline and distance from goal line. The first time when the player kicks the ball, he's 8 yards from the sideline and he's 15 yards from the goal line. Then the ball lands 55 yards from the sideline, order is important here, and 30 yards from the goal line. So 2 points, and we want to know how far the ball was kicked, so we want to know the distance the ball was kicked, so we'll use the distance formula. X sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. We're going to take the square root of that sum. Numbers get a little bit big and ugly here. 47 squared is 2209. 15 squared is 225. We'll add those up. Get the square root of 2434, which is approximately 49.3 yards. So the ball was kicked 49.3 yards. All right. Now let's deal with midpoint. Halfway between these 2 points. So if we drew a straight line between these 2 points, what would be what point would be the exact same distance between each of these points? Well, the midpoint formula, midpoint of a line, is the sum of the x values divided by 2 and the sum of the y values divided by 2. So we'll just do 5 plus negative 3, which is the same as 5 minus 3, divided by 2. And we'll do negative 1 minus 7 divided by 2. So we get 2 over 2 and negative 8 over 2. So our midpoint, halfway between those 2 points, would be 1, negative 4. And, if you want to check it, then grab a coordinate plane, plot the 2 points, plot 1, negative 4. You'll see that 1, negative 4 is the same distance from 5, negative 1 as it is from negative 3, 7. So, real-world application here. There are 90 feet between consecutive bases on a baseball diamond. Kind of useless information there. Suppose third base is located at 10, 0, and first base is located at 100, negative 90. A ball is hit and lands halfway between first base and third base. Where does the ball land? Some might just say the pitcher's mound. I don't know if that's entirely accurate, but we don't even have to make the coordinate plane, but if you need to look at it, this is point 10, 0, this is point 100, negative 90, so really this should kind of be flipped around, but it just doesn't matter because all we need is the formula. Add up the x values, divide by 2. Add up the y values, divide by 2. 0 plus negative 90 is the same as 0 minus 90. And the point where this is going to land, if this were on a coordinate plane, would be 55, negative 45. Kind of a goofy way to look at it, but it doesn't even matter which way you orient the baseball diamond. It just doesn't matter. M, this point right here, would be at 55, negative 45, if that's 10, 0, and that's 100, negative 90. Don't worry about the fact that they're both even with each other up here on the y-axis, but one says negative 90 and one says 0. Don't even worry about it. All right, so distance formula, midpoint formula, really not much to them. It's really going to help you in geometry, next year honors geometry, knowing these going in there. Your ninth grade teachers will definitely expect that you know them. So see you in class tomorrow. Good luck.